Yes. Now, the problem is that increased co-ancestry limits the population structure. And for that reason, we end up having low quality of breeding stock, limited supply of genetically improved animals, and lack of technically trained personnel also limits the production of goats in a validated manner. Inbreeding is also one of the major problems that we face under goat productions. And currently, to show that, there's 29 goat breeds that are extinct, and there's 11 that are currently endangered. Now, the reason for the study was because the genetic distribution of an animal gives the maximum potential. Previous studies have been done for cattle and other goat breeds, but not for the Kalahari red goats. Therefore, it's important to know the acceptable inbreeding levels for your goat breeds to be able to continue in long term. My objectives for the study were to determine the Kalahari red goats inbreeding coefficient from 1977 to 2018 in South Africa, and to determine the effective population size across generations from 1977 to 2018 as well, and to ascertain the risk status class of the Kalahari red goats. Now, these were my null hypotheses that the inbreeding coefficients are the same, that the effective population sizes are the same throughout South Africa, and that the Kalahari red goat is not at risk of extinction. The study was conducted broadly in South Africa, mainly in the northern, eastern, and the southern region. This is my study animal. This is the dew, and this is the bark of the Kalahari red goat breed. So my data was obtained from South African Stud Breeders Association and the Kalahari red goat breeders association under the stud book. There were a total of 17 generations, I'm noting an error, and under 72 breeders. There were a total of 26,203 animal records, of which we required the male, female, the sire, the dam for each animal, birth weight, animal ID, the season of birth, breeder, sex, and the region. After editing, so my data was obtained in Excel format. So after editing, this is what I ended up with. During the editing process, we removed all the animals that had dubious information and that the records were not clear enough. Therefore, that's how we ended up with the 26,000 animals, of which initially it was 29,000 animals. The number of breeding females was 16,000.7, 9,410 for the males, 72 breeders, 17 generations, and those are the regions more defined: Mpumalanga, Gauteng, Northwestern Limpopo, KZN, Eastern Cape, and so forth. The reference population is the population which had both parents that were noted, and the ancestor contributing to the reference population was 2,469. To analyze my studies, I used NDOC 4.8 and the following formulas for both the effective population size and the coefficient of inbreeding. And then for the risk status classification, I used a rubric which was provided for by DAF. In my results, I found out that there was an average of 4.3% inbreeding coefficient, with the mean inbreeding of 6.5%, 2.65%, the mean relatedness at 1.80. The expected inbreeding caused by unbalancing of founders was 0.32. Mating between full siblings, half siblings, parent to offspring were 0.36%, 3.98%, and 1.21% respectively, whereas the maximum inbreeding was 0% in generation 1 and 2, of which the reason for that, I believe, is because that's when the Breeders Association was only being developed. Therefore, there was no any other trace for parents that could be found for the animals. And also for the second generation is because it was the first generation to actually mate, so the inbreeding coefficient there was quite minimal. Although in generation 7, there's generation 7. That's where we had the maximum number of inbred percentages. And inbreeding affects an animal in such a way that it becomes deformed. The legs would be crippled, the production levels would drop, the milk production would drop as well. So for every 10% of inbreeding that you actually is implied on an animal, there's 20% in functionality of that particular animal. So from here, with where there's like the highest inbreeding levels, the animal, it was 6.62, of which from here, the number of animals started dropping because they were experiencing deformities. Now animals, it was noted that animals are mating with their parents, their siblings, and also their cousins. Here is a more detailed view of it. So from generation 7, here's the 6.2. From there on, the population numbers dropped until in generation 16, we had 41 animal records in total, of which the number of females was less than the number of males, which is not what should be required for the animals to breed effectively. And here's the graph that indicates the inbreeding. So with the higher number of animals that you have, the less inbreeding that you actually will have, because the animal would not have to breed with the closely related animal to it. And then for the effective population size, the reference population was 17,945 goats, and the ancestors contributing to the reference population was 2,469. The base population for one or more unknown parents were 8,228. The effective population size was in generation. This is the acceptable inbreeding level, whereas when you are in this state, we say now that your breed is safe. So under this particular point, that's when the breeding, the inbreeding level, the population rates were actually safe. But as we can note, out of generation 16 and 17, the breed was not under good population statuses. For the risk classification status, the risk status classification, this was the rubric that was used. We can check the results on the side. At the beginning, the breed was not risk at all until when it got to generation 14, when it was considered endangered. And thereafter, if we check at the last generation, which was actually in 2018, we would say the Kalahari red goat is endangered. So the inbreeding coefficients are not the same throughout the generations, and the effective population of the Kalahari red goat in South Africa are not the same, whereas the Kalahari red goat is currently endangered. Therefore, it'll be quite difficult for it to survive in the long term should the trends continue in the same pattern. In conclusion, I'd like to say the higher the effective population size, the lower the inbreeding level, and therefore the risk status classification of the animal would be safer in future. What I would recommend is that there would be intense conservation and increased population for this breed, and that we maintain and improve the elite breeding animals, the males and the females. Also, we should have advanced statistical methodologies for genetic evaluation, as well as assess genetic progress and develop breeding objectives, as well as assess traits of economic importance for the Kalahari red goats. I would love to acknowledge my beloved Department of Agricultural Economics and Animal Production, my supervisor, Prof. Tada, and Mr. Nemo Tandani for their patience in me and for guiding me through it. I would like to also appreciate NRF for funding me and the Stud Breeders Association for actually providing me with the data. Thank you.
Thank you, Ms. Rapele. I was waiting for you to start saying that these animals have started mating with their granddaddies and grandfathers. I was going to say it must stop. Can we please have questions, please?
Thank you for your presentation. Let's say we have sent you as a consultant to these farmers. what advice would you give them to reduce the inbreeding in their farms?
First of all, if I am a header of the animals in my particular head, if I were to continue breeding within them, that's when the inbreeding levels are going to be high. So I would advise them to actually interact with the other breeders around so they can actually exchange genetic material and then be able to avoid the inbreeding levels.
Any other questions? This side.
After the seventh generation, you indicated that the population size was coming down.
Yes.
But when I looked at the F values, the inbreeding coefficient, it also appeared to be going down, which is contradictory to what I would have expected.
It was supposed to
Go up.
go up.
Yeah, if your
The inbreeding
population is
coefficient.
going down,
Yes,
then I would expect F to go up.
yes, yes, yes. Hence
But
I
it
meant-
was going down.
No, it was not.
Oh, maybe I didn't see properly.
Yes, hence I said in the conclusion that when the inbreeding coefficient is, when the effective population size is high, there will be low inbreeding coefficient. Yes, yes, and that when when there's a low inbreeding coefficient, the risk status classification will be safer now. Yes.
Yeah, because the graph which I was looking at was the one where you had the inbreeding from the first generation going up.
Yes.
You got to the highest, I think it was like the seventh
Uh-huh.
generation.
Yes.
Then the graphs started going down. What was that which was going down? I thought that was F.
No, yes. Okay, I'm not sure if I understood you correctly, but on the graph, right? So when the population goes up, the inbreeding is gonna go up. No, it's gonna go down. So hence, there are two different graphs. I don't know if you could go back to them, where the population sizes are actually going down. So the one would be going down, and then on the percentage inbreeding, the graph actually goes up. So that's where they actually differ between the two. Yes.
Okay, thanks. Just one question before we clap hands for you. Why has it been so elusive for people to work on the Kalahari red goat? Why have they not been working on it?
It was shadowed by the Boer goat. So this is how the Kalahari red goat came about. It's from a Boer goat, a mixture of a Boer goat. So what happened was that during 1977, the farmers, when the goats would give birth, they would note there was a red coat on some of the goats. So they started isolating them and recording their data aside. Therefore, the Boer goat already had gotten attention. So only later on was the Kalahari red goat recognized, and that's when it started receiving attention. Thank you.
Thank you for the clarity. I think I've been schooled. I'm going to now jump to Matsane, but I just want to check, good people, before I jump there. Mohashwa, is Mohashwa in? Or are you finally back from lunch? After Matsane, just be ready, right? Yeah, so I'm asking you to be ready for that. Matsane is here. Okay, thanks. Sort it out there. Yeah. Okay. 2 fingers means start. If I've got my book on my face, it means you've got 8 minutes. For the last time, it means your time is up.
Afternoon, everyone. I go by the name of Matsane Velem, and it's Mr.
My bad.
Yeah, I'm going to take you through my research entitled Modeling Suitable Epitents for Artemisia afra using Maximum Entropy Model in the Sekhukhune District Municipality, South Africa. That's me. That's the outline of the presentation to be the introduction. Plants were previously the primary source of medicines worldwide, and since then, plants continue to provide humans with new remedies, of which 50% of all the drugs used clinically are derived from natural products, of which small plants contribute 75% of the total. Medicinal plants plays an important role in basic healthcare, mostly in developing community countries, with approximately 80% of the people depending on traditional medicines because of their affordability and cultural acceptability. Despite their basic health benefits, medicinal plants are facing serious threats worldwide, which may lead to mass extinction in the near future, influenced by the climatic condition and anthropogenic activities, which are anthropogenic activities such as over-harvesting and climatic conditions such as dry periods. With no exception to Artemisia afra. Artemisia afra is a woody, long-lived shrub. It's an indigenous plant that is brutally harvested due to its wide spectrum of medicinal benefits. After it gained much popularity to be preventing or curing the coronavirus infections. South Africa is home to more than 30,000 plant species, of which at least 65% of those plants can be used for medicinal purposes. In the Sekhukhune district, for instance, many people have been reporting the brutal harvesting of Artemisia afra. Therefore, it is needed, or it is important for one to understand the spatial distribution together with the environmental variables that contribute in the growth and the distribution of Artemisia afra species for conservation purposes. So the purpose of this study, it was to use the maximum entropy model in predicting suitable areas for growing this plant. Figure 1, it just demonstrates how the plant looks like, because as I was collecting data in the field, I realized that many people, they just know the name, but they don't know the plant. The purpose of the study, first is the aim. The main aim of the study, it was to assess and evaluate the contribution of environmental variables within which Artemisia afra can grow, and use them to predict the potential areas where we can find this plant or where we can grow them. The objective, it was mainly to use environmental variables in determining suitable areas. The methodology, will start by describing the study area. The study was conducted in the Sekhukhune district, which is located in Limpopo province in South Africa. The study, it covers a total surface of 13,528 kilometers squared, with the average summer temperature of plus or minus 23 degrees Celsius, with annual precipitation of plus or minus 565 millimeters, and an altitude of plus or minus 494 meters. During field data collection, we validated these claims that are presented here, that on the study area, 75% of the land is being used, or agricultural, it's subsistence farming, and 30% is commercial. Moving forward will be the data acquisition and pre-processing. Field survey was conducted from the 17th to 20 February 2020, where a GPS device was used to record a total number of 105 sampling points for Artemisia afra. And then the points recorded were later captured in Microsoft Excel for cleaning and preparation. And then later on, the data was divided into two, which was 70% for training and 30% for testing. That is just to show what the GPS looks like. Continuing with data acquisition, for topographic data, a digital elevation model was downloaded using the link provided. The DEM that was downloaded, it was having 30%, 30 meter spatial resolution. And the purpose for downloading the digital elevation model, it was to generate slope, aspect, and elevation for FET. For climatic variables, a total of 19 bioclimatic variables was downloaded using the website provided below, but it was accessed through Google Earth Engine, where further 7 of them was selected based on the gain when we used in isolation. You get to understand the isolation as we move forward. And then imported into ArcGIS for resampling and reprojecting, and later to convert to suit to the standard of the model. Following is just the demonstration of the default page of the model that was used. It's a spatial distribution model originating from the statistical machines. The model used only well using small sample size. And the model was, the software that it runs the model was downloaded using this link provided below. Moving here is the results. The findings from the study revealed that elevation was the most environmental factors that had much influence on the spatial distribution of Artemisia afra, as we can see here, is the one that has a high value on these graphs. So using the default settings in the model, we identified the contribution of each environmental variables using this graph. And this figure is just a summary of a jackknife results from the model, where the red bar represents the results when the model was run using all the variables, and then the light blue, it's when it's the gain loss when the model was run using when removed one variables, and the dark blue, it was the gain when variables were used in isolation. Continuing with the results, area under curve was just used to evaluate the performance and the accuracy of the model. So the value here, the blue line represents the fitness of the model in the testing data, while the red line represents the fitness of the model in the training data. So since these values are greater than 1, it means the model performed well with high accuracy, and then separation was better, sensitivity was high, and then the value is also closer to 1. Following is the result map, where it shows areas where we can where the predicted areas, where the red color just represents high suitable, and then the orange represents suitable, and moderate suitable with the yellow, and then light, low suitable, the light green, and then dark green is unsuitable. Discussion. Based on the findings, we found that elevation together with soil moisture, they had positive contribution on modeling the spatial distribution of Artemisia afra, where most distribution or high plants were found to be distributed in high areas, high-lying areas like in mountains, and then few distribution was found in low areas, and then other was found in most regions, as it's shown just in the pictures, and the results were in line with the following studies by these following authors. And then in conclusion, I'd like just to present the successful application of the model in modeling the spatial distribution of Artemisia afra, and overall, the flexibility of using this model, it can assist in making informed decision based on conservation and reintroduction of the species. And in future, other studies, they can consider using presence and AMSET data, and also add bands from space-borne multispectral remote sensing, and also other variables such as soil as the input data. I would like to acknowledge the following and send gratitude to my supervisors. The reference, and thank you. This marks the end of my presentation.
Thank you, Mr. Matsan. You took your time there, more than 12 minutes. 12 minutes, 15 seconds to be exact. That gives us about 2 questions, good people. That's the first. Can I get a second hand? I know there's a hand coming from there on the accuracy of your model. Okay.
No, I think I'll jump that question because I was about to ask it. So this is a very interesting study, especially if you're looking at the growth and the conditions and all that. So then one has to look at, I think for future studies, you can just look at the discrimination of this species from the others in terms of using the sensors and many other. I think you're going to go to that extent. But I think the question would be, so elevation is important and soil moisture. So the question would be, at what elevation, lower or higher, and at what soil moisture? Is it lower soil moisture or higher soil moisture? So I think that is the interest there, because you said those are the 2 important variables that would then determine the suitability and, of the growth or the growing of that crop. Thank you.
Okay, thank you for the question. I'll just quote from the keynote speaker who was speaking in the morning. He mentioned something about when you run a model, what happened behind the model, actually we don't know. So I just normally, and then it ran.